Title of the first section today is multiplication. Property. Of exponents. In this section, we'll look at the multiplication property of exponents. The definition or formula for the section: x to the power of a times x to the power of b equals x to the power of a plus b. What this means is if you have x, which could be, again, any number or any variable, to two exponents, when you're multiplying, we'll be adding the exponents a plus b. First question: x to the fourth power times x to the third power. Again, if you have the same variable or same number, we can add the exponents, so our final answer would be x to the seventh power, 4 plus 3. Second question: 2 to the fifth power times 2 to the third power. Again, if you have the same base, the same number being raised to the exponents, that number 2 would stay the same, and the exponents we can add 5 plus 3, which would be 8. If you have 2 to the 8th power, we can actually simplify that. This would be 2 times itself 8 times. If we write that out, it'd be 2 times itself 8 times. Multiplying, 2 times 2 would be 4. And we can multiply each set of 2's, so we get 4's. Multiplying again, 4 times 4 would be 16. And multiplying the other 4's, we'll have 16. So our final answer will have 16 times 16, which if you multiply that out, it's 256. So the final answer, 2 to the 8th power, which is equal to 256. And last question for the section: y to the 5th power times y to the negative 3rd power times x squared. The multiplication property of exponents can only be used when we have the same variable or same numbers. So the y values we can combine. Y to the 5th times y to the negative 3. Adding those together, 5 plus a negative 3 would be 2. And the x squared we cannot combine, but we'll leave it the same in our answer. So our final answer would be y squared times x squared. Title of the last section today is more simplifying exponents. In this section, we'll continue to use the property of multiplying exponents. First question is 3r times r to the 4th power. Simplifying this question, if we have a single coefficient 3 and there's no other coefficient or number to multiply by, the 3 would stay the same. R times r to the 4th. If you have a variable without the exponent, you can always add a 1 on there. So r is the same as r to the 1st power. And again, when we're multiplying the same base, the same variables, the exponents we can add. So our final answer would be 3r to the 5th. Second question, in parentheses 15, a to the 3rd power. times a second parentheses negative 3a. Multiplying again, the coefficients or numbers in front of the variable we can multiply. 15 times a negative 3. That would be negative 45. And a to the third power times a. For a, we can change as a to the first. The same variable or same base, we can add the exponents, which would be a to the fourth. So the final answer, negative 45 times a to the fourth. Next question, x to the fifth power times x to the fourth power times x to the third power. In this question, all the bases or variables are the same, so we can add all the exponents for our final answer, which would be x to the exponent of 5 plus 4, which would be 9, plus 3 more would be 12. So x to the 12th power. And last question for the section. 5y to the negative second power times 2y to the negative fifth power. Again, the coefficients or numbers we can multiply first. 5 times 2, which would be 10. And the variable y, we can add the exponents. Negative 2 plus a negative 5, which would be negative 7. Anytime we have negative exponents, we can simplify those, if you remember from previous sections, by writing fractions. So our final answer, 10, would stay the same. Making a fraction, the negative exponent would go to the denominator or bottom of the fraction. So instead of y to the negative 7, we'll have y to the positive 7. So our final answer is 10 over y to the 7th.